trade
super
school. It's not.
expensive.
There's no. I don't meet people from there who have this love of
Students
computer
love it.
science. Maybe one person from there has it. Like it's more like, oh, I need a job that pays more. I don't have. There's not like. They're nice people, but like if they're gonna like attack me for telling someone who's broke not to go there, like. And they do this entrapment, like they'll have these open sessions, and there's some people they just don't have a lot of money and they're like considering it, and I was like, I was just trying to help.
Crazy.
I was like,
no, that's awful. They shouldn't be praying.
I'm definitely not gonna be like the defender of these boot camps, but suffice it to say that
they attacked me, but I was like, I told my friend, oh, do you have rich parents? You should do it. Like, but he's like, I was like, if you really,
if you, particular.
I was like, if you really, I was like,
right?
no, I'm not attacking you or them, but I was just
Should
like,
I try starting
if
another
it's too
stream?
hard for someone to learn basic web design on their own, I'm like, why? Consider it before going into a boot camp. So if you're, if you really want to do it, it's like people spend money and go on these weird vacations to these tropical islands that
extreme.
that look kind
Yours
of
says
boring.
extreme?
Yeah, it says it's like strange.
But they were like completely attacking me. I mean, they're cool. And I just feel like there should be this level of learning in someone, like,
Okay.
I have these like really weird ideas about education, so like I'm kind of distressed at what's going on right now, but I don't know how to talk. I'll end up talking a lot, but I just feel like people should be education before the sake of the
So
world.
let me see.
You should have sent them to Cyber Wizard.
Yeah.
Huh?
Exactly.
Oh, cyber. I told.
I can't even kill this. It's just gonna run forever. I put it in a while ago. Oh shit, you can...
I was like gonna try the free host.
Oh, hang on.
Okay, audio sync.
But supposedly your Google Drive is it gonna be gross if you use my freaking
We are live streaming.
Google
Someone just needs to post a link to Twitter.
in Amazon Web
Cool. Post a link to Cyber Wizard first, and then I will post it on my Twitter.
Should I close this?
Yeah, you should probably close the screen. It's probably playing here.
Okay. So what is static is I mean, like, what would you have to have to not qualify it during, I guess, if you hosted?
Well, I don't know all the details of hosting, but I think like if you have like a project that's on GitHub already, it's like a really nice and easy way to sort of put like a landing page, like an information page for it. I mean, there might be ways to like, sort of connect to a database and like have
Need a nap.
routing and all that, but I'm not familiar
Why are you
enough to say.
talking about
Yeah.
Cyber Wizard DT.
Hmm?
Cyber Wizard DT.
If someone has a long mini jack to mini jack that they can bring tomorrow,
There it is.
then we can have better audio for this.
What is it? I mean, I'm pretty dumb. Should I Google it? What does it look like?
Mini to mini? It's
Yeah.
like what's on the end of your headphones to another what's on the end
Oh,
of
I
your
have
headphones.
only a short one. So you need it really long.
I might have
Like
a
two
long
over
one.
there.
Alrighty then.
Yay!
Okay then. So, today, if you look on the calendar, we are, now that everyone has their systems properly configured so that we can be effective, we will be covering the command line. And all of the wacky stuff that you can do with the command line. So, let's see. Anything else we need to cover before we properly dive in? I don't think. Okay. So, I think the first thing that you want to do is get your laptop out, if you haven't already, and open up a terminal, one of these things. And just have that handy because a lot of the stuff that I'll be doing, you'll want to follow along once we get into it, because it's really fun, and that I think is the best way to learn things. Just playing around, taking pieces and changing them and doing all kinds of wacky stuff. That's that's I think the best way to learn. At least it is for me. So first, before we can really talk about the command line, we should talk about some history. So Unix is an old operating system that came out of MIT in like the early 60s. They were called Multics. But that project between General Electric and AT&T, Bell Labs, and MIT didn't, being a big, gigantic project that was a conglomerate of a lot of different people, was not really effective, and it kind of fell apart. But out of that project, a lot of people, especially people like Ken Thompson and Dennis Ritchie, decided that, wow, they were really onto something there. I mean, they didn't really fully realize that vision. We could probably do this better. So over the course of, I think, a month, they put together a completely new operating system, because you can do that. If you are operating on really simple systems, I think they used a PDP-7 or something. Just some old closet computer that nobody was using for anything important. It's really good to have a well-stocked closet of just junk like that, I think. Is the lesson we can take there. But so, Unix is a really important operating system that has a powerful legacy. So all of the computers that you should be using now, because we dual booted any Windows computers in the room, are running a variant of Unix. So Linux is derived directly from Unix, and also OS X is based on a Unix kernel. It's based on a BSD kernel. Android phones all around you, including a lot of systems that you might not realize are running some kind of Unix, like DSL modems are running BusyBox Linux a lot of the time, or Wi-Fi routers are running a kind of Linux variant. So anyways, the reason why people needed an operating system at the time was the problem of how do you get computing resources that were very expensive to be shared effectively. So it used to be that you would have to take a deck of cards that was your computer program, and you would have to hand it to the computer operator, who would then feed it into the system manually, and maybe the next day or maybe a few days later you would get the results of your program. That wasn't very great. If you had a bug, you would have to fix it with a day or more of a delay. It was really not great for getting stuff done. So this early need for a system for providing remote access and time sharing was really important. Time sharing is basically is a technique where you can run different programs at different times on the same hardware, and it sort of automates the process of like a person scheduling the jobs manually. So one of the other interesting ideas from this era that is still pretty relevant in terms of how we compose computer programs was the role of the teleprinter. So on a mainframe computer, it didn't have a screen, right? And a screen wouldn't even be that useful, because if people submit jobs as stacks of cards, they don't lobby for the screen to show something and like write it down really fast. So instead, they printed out the results of their programs to paper tape or a line feed printer. So these were actual machines, and what was cool about teleprinters in particular was that you could remotely access a system, and so it had a keyboard and you would type onto it. That was like the input, and then the remote system would go and do something. It would schedule your program to be run with a wire or over a telephone later and print them directly to a printer. So it was this really early idea of this thing that we'll be diving a lot more into detail later, of having this kind of, it's called a read-eval print loop, or REPL, where you can type a bunch of commands and see the results. So that's the basis of that idea. But later, there was this new kind of machine called a terminal. This is like a teleprinter, but instead of just printing to paper, and you'd have to, if you're out of paper, oh, you can't use your computer anymore. You have to go down to the store and get some more. So instead, onto these computers, and then you could see the results. The computers themselves didn't really do very much because computers were very expensive, but these machines were less expensive. So people could have a lot of different terminals that would connect remotely to these mainframes that were running some kind of Unix or whatever, some sort of time-sharing system. So anyways, all of that brings us then into the microcomputer era, and this is where those terminals with the screens on them that didn't really do very much originally, they had some circuits, but they didn't really have any memory or anything like that. Those were replaced by real computers with a real CPU, real disk, real floppy drive, all kinds of inputs and outputs directly locally on your machine. And this was a difference to the old system, but a lot of the good ideas from the old mainframe era were carried into the microcomputer era, and they're still with us because they're useful ideas that are worth thinking about, especially for programming tools. They're really great for that. So we don't use any of this stuff anymore, so why am I telling you about it? Well, here's one thing that we do use a lot, especially in programming, especially we have this notion of standard input and standard output. Early days, this was literally standard input is the output. So it's like you have your input and then you see the output. It's a very, very direct kind of loop. But all of these ideas are baked into every computer program that you might want to write. So these are just primitives available to any program. You can use them as much as you want. So we'll get more into standard input and output later because it's a really important idea. But first, so it's important to think about how an operating system, or especially how Unix operating. So there's three main sections. That's kind of the lowest level that talks things like that. Then there's the shell that commands that you type in and running them. So it's like then there's just system utilities, so whatever the operating system comes with, and then plus whatever you've installed. So the kernel, in a little more detail, it's a program that kind of sits in between the other programs that you want to run and the system hardware and the file system and things that are shared resources on the system. So the kernel needs to do input-output, so it needs to know how to speak to a variety of different hardware devices, like different keyboards, different monitors, different graphics cards, and disk drives, and all kinds of things like that. It also talks directly to the CPU, so, well, it kind of is the layer that schedules pieces on the CPU, so it has to balance a lot of different programs with different priorities that need to occur. So, like, if one program on a system has a while true loop that just executes infinitely, it shouldn't completely hose all of the other processes that want to try to run on the system. And then the kernel also deals with memory. So when your program needs a bit more of the system memory to perform a calculation, then it can access that through the kernel. So the Unix, the basic operating system handles all of that kind of stuff. Like yeah, anyways, so kernel does all of that stuff. But so the next thing in sort of how an operating system is organized is a shell. So a shell is like this. It's sort of just a program where you type some commands, and we'll be doing more of this later, and you type them on standard input and you see the results on standard output, which is just the screen, so you look at them. But modern shells are actually very, very similar to the original Unix shells in terms of a lot of different features. They're just, a little bit fancier, a little bit more refined, but the basic ideas are pretty much unchanged. So the next layer is all of the utilities, and we'll be talking about a lot of the different utilities that you're likely to find and use on a Unix system, and kind of how you can take simple, small programs that sort of do a very specific task and combine them to do more complicated, more custom tasks. That's a really important idea in Unix. So the original reasons for the popularity of the Unix system are kind of still holding strong in a lot of ways. Like, originally, Unix was made to so it was common in that era in the 60s and 70s for computer manufacturers to make custom operating systems for every different piece of hardware. So like BASIC or like Amiga would have its own operating system, and it was like custom, and programs had to be written for that specific device. And you switch to another system, they do things completely different. Which was very useful because it means that you can share programs very easily. It also provides a lot of consistent conventions like standard input, standard output, file system access, memory access. And this is increasingly popular, vast software ecosystem, especially a vast open source software ecosystem with Linux and GNU project and things like that, and text, and a bit more on that. So yeah, I talked a little bit about how you might see Linux running on like a web router or a DSL modem or something, but also a Raspberry Pi, and you don't need to learn like a whole Raspberry Pi versus if you're hacking a desktop or whatever. Kind of use those in all kinds of different contexts, which is very nice, I think. There's a lot of conventions that are important too. Okay, so this is a really important, really nice thing about Unix systems is that they're text-based. And that's important because if you need to access a computer that doesn't have a screen attached to it, or that doesn't have a screen that's right in front of you, then you'll need to somehow interact with that system to get it to do what you want. On another computer, you can run things and you'll see the output in your terminal. So, or if you need to hack on like a Raspberry Pi, for example, that doesn't necessarily, but you can do things on the Raspberry Pi without sticking a big clunky power-hungry monitor into it all the time. So there's this great part about Unix that I think is really, really fun and really, I don't know, there's something about this whole idea about, it's like the craft of building computer programs in such a way that they're simple and easy to learn and composable, called the Unix philosophy. And this is one of those design principles. There's this great book I've only read the first chapter, which I think is almost everyone's experience of this book, but it's called The Art of Unix Programming. And this in particular, section 6, is fantastic. It's like a laundry list of a lot of different ideas that are involved in a lot of the Unix programs that you might use every day. Like one of them is really good. It's called the rule of silence. It's this idea that if a program has nothing important to say, it should say nothing. The original reason for this is if you have a teleprinter, then you don't want to waste a bunch of paper and ink on like messages like, okay, it worked, and messages when there's this not only optimized for printing and like things, but I think that it's still relevant because it's a good problem. The less you have visual scanning you have to. Here's some more tenets in the Unix philosophy that I think are really good. So this is like a direct quote from folks like Doug McElroy, who was involved in the early design at Bell Labs. So make each program do one thing well. To do a new job, build afresh rather than complicate old programs by adding new features. So instead of building one big program everything, instead you can just build several small utilities or narrower but more abstract kind of input and output, and then you can compose them. Expect the output of every program as yet unknown program. Don't clutter output with extraneous information. Avoid stringently columnar or binary input formats. Don't insist on interactive output. So this first part is a really good idea because it lets you collaborate with people you haven't even met yet, or maybe you'll never meet them, right? If you write small programs that just do one thing really well, then other people can take your work later and kind of build upon it much more easily than if you built a large, complicated program that tried to do everything, and then it's always harder to add stuff to a big program than to just string some small programs together.
Interactive input?
So interactive, don't insist on interactive input. This idea is about how you shouldn't force a human to sit at the computer and type things in. You should make your programs easy to script. So you could, for example, build like a GUI interface, or like a curses interface it's called, where you do a lot of clicking and like using the arrow keys and things. But if you build a simpler program, it's much easier to write a script that can run that program for you. So you can save yourself.
Another thing? The other thing is like some programs will say like, do you want to continue? Yes. And like if you can avoid that, like that slows down all kinds of processes for people if a human has to attend to it while it's running.
Yeah. Okay, so the third part of the Unix philosophy, I think there's 4 parts, I think. Design and build software, even operating systems, to be tried early, ideally within weeks. Don't hesitate to throw away the clumsy parts and rebuild them. So this idea is related to the previous idea about building small pieces. Build small pieces, and the nice thing about small pieces is you can build them quickly, and if you don't need them, you throw them away, instead of building a big program that has away because it's all tangled up with everything else. And if you can throw things away, then you'll end up with much. Unix philosophy is to use tools in preference to unskilled help to lighten a programming task, even if you have to detour to build the tools and expect to throw some of them away after you've finished using them. So this is a recommendation to not rely on like grad students or whatever help you might have around. Really sharp, do things very well. So, all of that aside, now it's the interactive part. So get out your terminals, and we'll be doing some Unix stuff. So, the first thing we should all do is you should type this into your terminal. You should type echo space $, and then in capital letters the word shell, like this. And you should see something when you do that, like this output. I think almost all of you should see something like /bin/bash. Bash is a very common shell. It was directly inspired by some of the earliest shells. Descendant of the Bourne shell, which was a descendant of probably more shells, but then one of the original people behind Linux wrote a shell that was popular. So we're getting into this kind of an idea where we did this thing. We typed a command and we saw the output. So this was the command we typed. These are the arguments, everything after the command name, and this is the output that we see. That's the standard output. So another fun command you can do if you've typed echo shell is you can do ls. So depending on where you are in the directory structure, and we'll get a little more into that in just a bit, you'll see different kinds of output. So if you type ls in your home directory, you'll see a different set of files than if you type ls in a different directory. Everyone good at typing ls? Okay, great. So the next thing to talk about is what is a command and what is an argument. So ls will list things in the current directory. So if you've navigated around a GUI with like lists of files, you have this notion of the current directory. It's all of the files that you're looking at, and you can go up a directory or you can go down into a subdirectory. If you want to list another directory with the ls command, you can just specify its name. So if I want to list the root directory, I can do ls space and then the argument that I give is like slash. Or I can do ls/lib or /modprobe. Other arguments too, like you can do ls and then this thing called a flag, or sometimes called a switch. Like if you do ls/ and then a hyphen and then number 1, you'll see the results as a list, or a list with every entry on its own line, instead of the default, which is for all of the entries to be expressed in like columns, basically.
You guys having problems?
It's fine. It's just it just wasn't working for some reason. It just started working again.
Sounds like your computer.
So play around a bit with the ls commands as I talk. And then you can specify an argument. You can specify more than one argument if you want. Not all commands take arguments or care about what arguments you give them. And if you want to specify multiple arguments, you just separate them by a space every time. So it's just all separated by a space character. So another command that's fun is called pwd. This stands for print working directory. So if you want to know where in the file system you are, you can print pwd. So I'm in, for example, /home/substack/data/unix. But if I was in another directory, then I'd be in /home/substack. And that cd command I'll get to in just a moment. But if you type pwd, you should see in standard output where you are. A lot of terminals will also, by default, configure. This is called your prompt. This part with the $sign and this text before it. This is sort of like a handy way to know where you are, but not all terminals will be configured like this. So it's good to also set it up. You're free. So another really useful command is to change the directory. So you can do this with the cd command. Cd stands for change directory, and it takes a single argument, which is where to go to. So if I type ls, I see that I have a few directories. Like if I cd space media, then I'll go from my home directory into the media directory, which is also my home directory. So now I'm in. See a difference. cd space 3d, and now I'm in the 3d directory. So we've gone all the way into this long directory, /home/substack media 3d, but now it would be good to go up a directory. So there's these special directories. One of them is .. This means the parent directory. So if you do cd space .. right now I'm in /home/substack/media/3d, but if I do cd space .. now I'm in just home substack media. So I just went up a directory. If I go back into that 3D directory, a fun thing is you can combine these special directories as much as you like. So if I want to go up 2 directories, I can do cd space .. which is going up the parent directory of the parent directory. The thing is, if you ever get super lost in a crazy place like Verilog, and you're just like, I just want to go back to my home directory, all that you need to type is cd, just by itself, and you go back to your home directory. Handy trick. So there's some other special directories you might see, like .. is the parent directory, dot is the current directory, and there's some times when you'll need to use like dot slash or dot for whatever reason. Tilde is your home directory, so if you ever see a tilde slash that else, but I is different. Might see that's kind of lesser known is so if I had multiple users on this system, I could do something like ls substack slash. So like directory, your home directory had permissions so that you could do that. There's this thing called Tilde Club that's like a website based around Tilde and home directories, but anyone can edit anyone else's website. It's pretty fun. Hop around with ls and cd and pwd and special characters dot and dot dot slash and whatever. Fun times. So so another command. So we can move around our system effectively, but what if we want to see what's in a file, right? So if we have a file, like here's some files in system log. If I want to see what's in one of these files, I can use the cat command. So if I see there's a file called debug. So if I want to see what's in that file, I can do cat debug. Permission denied. So I can do this command called sudo, and then I can actually see what's in that. Sudo means do this command as the system super user. But the important part is that cat can display files. So if I have some files, I can make one pretty quickly. I'll get more into how you can use Echo to create files in just a sec. So if I have a file called blah, I can print out the contents with cat. It's a handy way to hop around your directory. So the nice thing about cat is it was originally written to concatenate files, hence the name cat from concatenate. And you can take multiple files. Like if I have a second file, so if I have a file foo and a file blah, if I cat foo blah, then I see each file's contents printed to standard out, one after the other. And you can put as many files as arguments as you like, so you could keep going with different file names.
Does it create a new file that is concatenated, or it's just putting them?
No, it just prints them to standard out, so it doesn't create any new files.
But the thing is, that little caret will direct whatever the content, whatever the output was of the first program into a file, right? So it only does one thing. It just takes stuff from the arguments and puts it to out. But what you it to file, you can do other stuff with it.
Yeah, and I'll get more into shell redirects in just a bit.
But yeah, he's gonna get it into that.
Okay, so that's the cat command. So another command we can use is called cp. This is a really handy program that copies the entire contents of a file from one place to another place. So something that you might want to do is, if I have a file like a.txt and I want to copy it, I would just want to make a copy called b.txt. You just say cp a.txt b.txt. So it goes cp source destination. So I can do that, like if I make a new file a.txt, put some a's in it, whatever, put whatever you want in it, cp a.txt to b.txt, now I have a new file called b.txt, and it's the same as a.txt, which is what I want. cp also takes, you can copy an individual file, but you can also specify a directory as the destination. So if I cp a.txt to tilde slash, which means my home directory, then if I we'll use the file name of the first argument as like the file name for the destination, or you could specify what specifically you want CP to name that file, like blah.txt. We'll make a file in my home directory called blah.txt with those contents. So that's the CP command. Also, all of these notes are available in the Cyber Wizard Institute workshop called Unix.markdown. So if you want to follow along on that, it's very handy if you need to. So I talked about CP directories. Another fun thing you can do with CP is it doesn't just take 2 arguments, it takes as many arguments as you want. So every argument except for the last argument is a source file. So if I want to copy, so I'll use this command really quick that I haven't talked about called makedir. It just makes a new directory called xyz. If I want to copy a.txt and b.txt into that directory xyz, I can do cp a.txt, b.txt, xyz, and now in xyz there are 2 files. That's a flag or a switch is just any argument that starts with the dash. Sometimes you'll see dash dash, sometimes you'll just see dash, but this argument is called dash recursive. So if I go up a directory, now in this Unix directory, remember we made that directory called xyz, so there's stuff in there, there's also stuff in Unix. If I want a copy of that entire directory and all of its subdirectories to a new place, I can use cp-r. So if I do cp-r Unix to someplace else, now there's a new directory called someplace else that has all of the files and all of the subdirectories. If I tried to do that without specifying /r, like if I just did cp Unix someplace else, I get an error because it omits subdirectories. So it didn't actually do anything. Among commands, so dash lowercase r or dash capital R is often an option for recursive. So there's an analog in the ls command. So if you want to see all of the files in a directory, you can use ls. But if you want to see all of the files and all of the files in any subdirectories, if you give ls-r, then you'll see not just Unix, not just the contents in that directory, but also the contents in the xyz directory, which is kind of handy sometimes. The -r command, both capital and lowercase, shows up in chmod and chown, all kinds of commands on your system.
For that, it has to be capital?
Yeah, for ls it has to be capital for some reason. That's just how they wrote it. Okay, so there's more commands. This one is called nv. It's like copying but a move operation instead, and it lets you change the. You can also use it to overwrite files and directories. So if you want to have a file like a.txt and you want to just change its name, you can do that by giving a destination argument, the second argument, to be like new name. So do that right here. So nv a.txt, dino.txt, and now but dino.txt of the previous a.txt. We can also move, just like the cp command, we can move files to new directories. So if we move dino.txt into xyz, and now it doesn't exist in this directory anymore, but it does exist in xyz. Rename directories just like files. So if you do an mv on a directory like xyz, if I want to call it zzz instead, then we just renamed it. So it's a really common basic command. So another command that's very useful is called makedir. Makedir is a lot. So I used this previously. It does exactly what you might think it does. It makes a new directory. You just type makedir we. Now there's a new directory called we. So I can cd into that directory and type ls. There's nothing in there right now, but if we made some files, then we can make new stuff. You can also create multiple directories at once. So if you do make dir one thing is there's this switch called -p, which I'll just show you how it works. So because that's the best way to describe how it works. So if I do make dir foo bar baz like this, it says to make dir inside of the directory. So inside of foo there's a directory called bar. Inside of bar I want you to make a directory called baz. But make dir is like, foo doesn't even exist. I can't even do this. So then you tell make dir, do it with -p. And make dir is like, I got this. So what make dir does is it makes a directory called foo for you. It makes a directory called bar. Then it makes a directory called baz. So if and again, it's like, oh, that stuff already exists. So we're good. We don't have to do anything. Be in a particular place. Sometimes flags will take values after them, sometimes not. It depends on the utility. But it's a common convention that, like, for example, with make dir, I can put this -p after the command, or I can put it at the end, and it does the same thing. But it depends on the command, because when you write a program that takes command line arguments, you get the arguments in an array. So depending on how you decide to parse that array, it could work differently, but this is a common convention.
What else does P work with, or what is P? Is it only make dir?
It's only a make dir thing, so
okay.
It's just something particular. Something particular to the make dir command. You can read about any command with the man command that I'll talk about more in a little bit, but there's a -p flag, so make parent directories as needed is basically what that stands for. But it's specific to make dir in this case. Okay, so a fun other thing, suppose we wanted to make these two directories, foobar baz and foobar qrs at the same time with -p. We could write it like this, like some sort of, I don't know, ridiculous, like. So if I remove that directory, so I could do make dir -p foobar baz and foobar whatever, right? That would work. There's a cooler way to do this though. So this would create foo bar, and then inside of bar there would be two subdirectories, baz and whatever. There's a tip to this. You can use this thing called brace expansion, where you put and a closing curly. So I'll use the echo command, which just prints out the arguments to show you what this would have expanded into, and then we'll run it. So this command right here expands this section out. It says it takes every argument, which is separated by white space, and it says, okay, make this into foobar baz and also make it into foobar whatever. So it lets you do these kind of cool combinations on the command line. It's a really handy, fun trivia thing you can use sometime to look pretty cool. Bar has a baz and a whatever directory, so it's a kind of neat little trick you can use sometimes. So the echo command that I've been using here and there just prints to standard out all of the arguments that you've given. It's also a really handy way if you've typed out something and you just want to see what it will be, because there's different things like environment variables and different kinds of expansions that happen on the shell, so it's a good way to sort of neutralize a command to make it not do something. Another way is to use a comment. Is you'll also see that sometimes. So that's more brace expansion stuff. There's another fun one that involves numbers. So if you want to just generate a list of numbers in the shell, this is a fun thing you can do. You can just do echo 1 to 10, and then it prints 1 through 10. Or if I want to add some text before every number, then I can just type like x equals, and then I get this sequence. F. It's pretty fun. Or you can do like 0x if you want to be like elite hacker, hex code stuff, whatever. There you go. Yeah, it's basically just magic. I promised you wizard spells, so here they are. If you want to list all of the integers from 1 to 100 inclusive by tens, you can add another dot dot and then a skip distance. So that will print
Wow.
different numbers.
Such good spells.
Yeah, it's a pretty good spell. It's like one of my favorite spells. Yeah.
Is the curly brace
The curly braces just do these magic tricks. It's something that the shell has built into it, so it's not a command or anything.
Okay.
It's not like this special abstract interface. It's just like some cheap tricks, basically, for
okay,
convenience.
so it's not like Echo, which is like Echo itself I imagine is a utility
Yeah,
that someone wrote, and so the curly braces is not itself a utility.
no.
Okay.
The curly braces are built into the shell. Most of the time when you see special syntax, it's usually part of the shell itself, like backticks or
It's like
parens.
white space, I imagine.
It's what?
It's like kind of like white space, like
Yeah, it's like white space is just something the shell does.
Yeah, it
it
knows
just
how to
parses things, and yeah, it has its own parser for all of this kind of stuff. So that's a fun little trick. It's fun to play with. You'll look really cool, impress your friends, etc. Getting back into some more mundane stuff, we can delete files if we want. So actually, why don't we use this to make a bunch of files, and then we can delete them. So there's this command called touch that makes a file. So if we this is what that touch command would expand into, right? So maybe, here's a cool thing. If you ever find yourself in a ridiculous hamstrung scenario where you have to make 1,000 files, how are you possibly going to do this? That's going to take you hours, right? So you just make 1,000 files like this, right? Called file 0 through file 1,000. Files like this. So that's what it will be when we run it. It's like if we typed all of that out by hand, like some sort of person who doesn't know the shell yet. But we do know the shell. We do know magic. So we just made 1,000 files. Actually, yeah, we made 1,000 files. No, we made 1,001 files actually, but you know, that's okay. If we want to make 1,000 files, we can delete the 1,000th file with this command called rm. Rm is like, it's just a command that will delete whatever file names you give it as arguments. So you can delete a single file like that. Now there are 1,000 files. Or we can delete, so if we want to, for example, delete all of the files that start with 5, like file 5, file 50, file 500, if we just hate 5s for whatever reason. Because we got issues, you can do this thing, you can add a star, and the star will, it's one of those special things that Bash does, where it will expand out to everything that matches this pattern. So I'll just preface this command with echo before we do it. So this command will expand out to be rm file 5, file 50, 500, 501, etc. So if we actually far fewer files with 5. It's missing all the 5s. It goes straight from 4s into 6s. So
If I could have one thing, but file 685 matches, because it'll beginning of what you said.
yeah. All
put star 5.
star
Put
5.
the star
That's,
in the 5.
we'll see. We'll see. It looks like that worked. Yeah. Correct?
Star 5 star.
Star 5 star, yeah. So anything, so this
Before and
means,
after.
yeah, anything
Ah.
before or after a 5 will match in this case. So this is called sometimes this is called a glob expansion or a wildcard or whatever. Fun trick, but the rm command just deletes the arguments that you give it. Rm can also delete directories if you want, so you might, okay, first of all, if you ever see someone tell you to type this or to type this, don't do it. For God's sakes, don't even type that ever. I felt weird about typing that at all because it's really dangerous. It will recursively delete because of the R, like the ls command or the cp command. Recursively delete every file starting from your root. And the F means force, so that means it just deletes whether it can or not. It'll just delete everything, and all of the files in your system will be gone forever. So Unix systems, this is like, with great power comes great responsibility. So don't type that ever. But if you do need to delete a directory and all of its subdirectories, like if I want to delete that we directory, and it has a subdirectory called foo, if I just type rmwe, that's not going to work because, it's not going to work because I typed it wrong, but it says cannot remove we is a directory. So if you give it these two switches, R and F, or just R in this case would work, but then it will delete that directory and all of its subdirectories.
So without the F, will it prompt you and say, are you sure you don't want to delete this?
I'm not actually sure. Why don't I create a similar circumstance and do it without the F? Because I just do the F always, because it just like always works more. I don't have to think about it as much, which is possibly a bad thing. But I'll just do it with the R. Actually, if I should make a file in that. Okay, so now if I do rm-r-zzz, okay, that also worked. So you could probably just do the R. You probably don't have to do the F, but people do the F a lot just because it's more dangerous. Do this. You can usually do this with single letters, but only sometimes. With a lot of the system utilities, you can string together. So like doing rm-rf in this case would be the same as doing it this way with a separate F and a separate R.
The other thing that you might learn from the man pages, which are the manual pages, is that a lot of the time, like -r and -f also have long forms, right?
Yeah.
So if you So
Right.
see, you can either do -r or -- recursive, and that's the actual flag. But the -r, they provide you with that little shorthand. But for ones that like they didn't like care that much about,
For shortcut.
but yeah, you can either use -f or --force.
That's the arm command. Don't delete everything. Okay, now for some more fun stuff. So this one is called WC. It is the word count command. And think, okay, word count. I'm not writing an essay for English class. What use could I possibly have of this? But it doesn't just count words. It also counts characters and lines, which are much more useful than words, actually.
Word count.
Yeah.
What'd you do?
He's been playing with files.
Did you delete all of the files
No.
yet?
I just made 10,000.
That's great. Okay, so the word count command will print out. I forget what order this even is, but it must be the number of word. I don't even care what these are, because how everyone uses word count is like this. This is how people actually use word count. So here I've got Moby Dick, right? I could do wc mobydick.txt. There's some columns. What do they even mean? If you use flags instead, like -w is the number of words, So that must be the middle one. Dash C is the number of characters, which is the biggest one. It's the third column. And dash L, this is dash C in the file. Dash W, you know, whatever. It's not English class. What's fun though is if you just type WC by itself, then what it's doing right now is it's waiting on that thing we talked about earlier, standard input. So it's waiting for you with your meet. If I hit some letters, I just like, okay, I'm keep typing WC, what do you want? What's your deal, right? So it's waiting for standard input to close. So you can do that by hitting Control D. And that sends a special signal to the basically. It's like, okay, I'm done with standard input. Control D, remember that, it's an important one. You could also do, if you ever get stuck in something and it's like, okay, whatever, blah, and you just want it to die without without like finishing up or whatever, you can hit Control C. And that's just like, I don't care about this program anymore.
And
Just get out of my face, computer.
and sometimes you have to do Control C twice for really persnickety things.
Oh, well, sometimes you have to just hold it down because there's like some other loop or something, like if you do this. If I do that, it's really hard to kill this program on purpose. It doesn't even, I can't even kill it if I hold down Control C. I actually have to do Control Z. I'll get more into that.
Yeah.
So sometimes it's hard to kill programs, but there's always a way. Unless it's in kernel space, and that sometimes gets really complicated. Anyways, what were we talking about? WC, right. So if we want to, for example, read from standard in the number of lines that I type, we can do WC-L. We can type some lines. So that'll be 3 lines after I did Control D. There we go, cool. So, an aside, I've talked a little bit about this. There's the man command. If you do man in the name of a command, man is short for manual. It's not short for Emmanuel, and it's not short for other thing. I don't know. I got nothing. Anyways, you type man in the name of the command, and then it gives you this sweet, sweet help file that you can read in your terminal. Just use the arrow keys, or if you want to be even cooler, use J and K to move up and down. That's what I do. Slash. Then you can specify like up info on the dash L, enter, and then I hit N to like skip ahead to the next match. Jump right to the info on the lines part. Yeah, Brendan, you had a question?
Yeah, can you do that with any utility, or is it just specific Unix?
The searching around, you mean?
No, the manual.
Manual.
Most
If
of the
you-
time. If you have the documentation installed for that command, if it comes with documentation, you can do this for almost all of the built-in stuff, unless it's part of Bash, in which case you have to read the manual for Bash, and oh my god, it's so long. Recommend that. But maybe, you know. So how man is structured is actually kind of. So if you put a and in particular, man is looking for this one called pager, and pager is actually just the name of a pager you could use is called more. So if I run down dash, sometimes it's 2 dashes.
Reading man pages on airplane flight or something, like when would you recommend learning that way? Why is that good?
Reading the man page.
Yeah, so just anytime you want to learn about any of the commands.
Anytime you really
best
want to
resource.
learn about
Good.
Well,
mostly.
something.
Oh,
Go ahead.
Mostly man pages are just a reference, so if you need to look up something specific, like does this command support this particular feature, this particular mode? But that stuff's really hard to discover too, so sometimes you just want to see what's there, just because.
Okay,
You get
cool.
all kinds of fun surprises. There's so many little commands, and they all like work differently, so. For years, and not know that it has this sweet, sweet flag that you've never heard of. So
It's
They're also
documentation.
like, you know, a lot of the time people think, oh, it's a like command line program because people are used to GUIs,
Yeah.
but there are command line programs that are like extremely powerful with loads and loads of things you can do. Like there are like command line programs for video editing, and they can like convert video type. Like you can do so much with them, and you might never find it unless you like were
Yeah.
like, hey, does this program do this, and
Yeah.
like just go through the.
or like there's this great one for audio called Sox. That's fantastic. Oh, like there's some really messed up cool shit in here. Like yeah. Oh wait. There's like a way to do audio synthesis. Like if I run this command. Complete insanity, but if I run this command
What?
on the fly,
Nice.
there's no sound file. That's it. It's just these notes and like this delay and fading and crap like that. There's some good stuff in some man pages if you take the
It's
time.
just free documentation that's on your computer.
Yeah.
Yeah.
You don't even need a network connection.
And it's the full it's everything that it does.
Okay.
That's like the hacker. That's like for people who know what they're doing too. So it's like it really cuts to the meat of it really fast.
So can I just
Which is
wax
good and
on
bad,
about
yeah.
like more? So the other thing is that like I think typically man pages will all follow the same format. So like they'll sort of have like a short description at the top, right? Name, synopsis, and they'll give you some examples like what does a typical rec argument look like, right? And loads and loads and loads of options. Kind of get a feel for what kind of information you're likely to find.
Yeah, like this kind of formatting is really common where they put like the switch and then a little blurb about them.
And the other crazy thing is that that format that you see in man pages is from paper manual. Like we have like a Unix manual that I found in the garbage.
Yeah.
And it was, and you open it, like, and it looks just like
Yeah.
that.
It's actually based on this program called format a text file this way. It's like built in, it's already installed on your operating system how to generate shit like this. It's fantastic.
And the programs that you were talking about, like the audio program, are like programs that can be run on the terminal and usually are GUI. Is it incredible because it's being run?
Well, the nice thing about having a program like this, it's not like a GUI where you have there's just some instructions about what buttons to click in what order and like what menu to go through. This is much faster to like share that piece of wisdom with other people. You can also edit this much more quickly than editing an instruction, and like you can I could change these values much more quickly and see the result much more quickly or hear the result. So it tends to lend itself better to faster iteration cycles, things on the command line, and also things on the command line. Like I could write another program to generate these arguments that I'm giving this first program, right?
There's a command line, search the internet. There's a search the internet from the command line.
Yeah, there's lots of ways to access external resources, but okay. So we talked a bit about how the order of arguments kind of most of the time doesn't matter too much. Also, some arguments expect the second thing its value, but sometimes that's not the case. So like with -i, this is like -n with the head command, and -n is written such that the next value is the end value. So you just have to be aware of how the documentation works to know that kind of stuff. So a bit more about absolute and relative paths. So remember how there was like dot and dot dot and forward slash. So if a path starts with a dot or a dot dot, that's a relative path. that means that that path is resolved with respect to the current directory. But if you have a path that starts with a slash, that means start at the absolute root of the file system. For example, like dots using a star, that's kind of handy. Or I could do ls slash, that's an absolute path, or like var log, and that would be an absolute path. So it's just kind of good to know when you're in either case, like when you want to use a relative path or an absolute path, and like what the difference is. And like the nice thing about absolute paths is they're going to be the same no matter where you are in the system, no matter what your current working directory is. So if I type cat /etc/issue anywhere on my system, I'll get the same output. It's not dependent on where you are. So if I did that with like //slashes, then it would only work in some directories and not other ones. So, talked about echo already. So just a quick refresher, it prints whatever arguments you give it. That's all that it does. Pretty much it's not handy until you start using this other feature, except to nerf commands by making them harmless. But there's this other feature called pipes that are built into shells. Pipes are how you can take commands and glue them together by taking the... Well, first of all, let's talk about redirects, I guess. I'm getting a little ahead of myself. So, you can use the greater than symbol to write the output of a command to a file. So, using echo, if I want to output that to greater than file.txt, for example. Now there's a new file called file.txt. It contains the output of that program. Just echo any command that you can be redirected into a file. So if I have the date command, for example, if I want to save the time, I can redirect to time.txt. That's fine. Now I can use cat to print out that content. So it's frozen in time at 4 p.m. 9 seconds. Never changes. So greater than means redirect to a file. There's also this fun thing you can do, or like we could ls. Now file contains, which is cool. There's append as well, so if you have a file, like say we have file.txt and we want to add entries to file.txt with another command, we could do, we could like add the current date to file.txt by using two greater thans, one after the other, which is append. Now file.txt contains everything it contained before, and at the very end we have the output of the date command, and you can keep doing that as much as you want with extra commands. A handy little feature. If you have a less than instead of a greater than, so basically the little arrows going left instead of right, that means standard output of a command. So for example, it's just hanging around waiting for. If I have that same program with a less than, we can take a file and just like, okay computer, use your computer fingers to type out this file into the WC command for me, because I don't want to type that. It's computer work. And then it does, and it prints out that, hey, there's 7 lines in that file, which is pretty cool. So, that's like, this is basic file redirects. So, you put it into a file with greater than, you can take two greater thans together as append, and you can add things to a file, or if you flip that greater than around into a less than, you can take a file and type it into the input of a program. Building on that idea, there's this great feature called pipes. Pipes are a way that you can take the output of a program and put that output into the input of another program. For example, if we do ls-1, this is a version of ls that prints each file on its own line. So maybe, what if we just want to know we could count them. 1, 2, that's computer work, don't do that. Instead, what you can do is take that command, ls-1, put a pipe character, which is like, it should be between backspace and enter. If you hold shift down, it's like that character. It's a good character to know. And then if you type a command like wc-l, if this command if this command opens up standard input, then the output of ls will go into the input of this program wc-l. And then we get the number of files in that directory, which is 6. We can give other options to our command too, like if we want to know how many files and directories are in the root. That many, 22. Cool. We didn't have to type with our attention, with our precious human attention. We can let the computer do that for us. So we can think about other things. Such as, how can we do a crazier thing? Like, what if we want to know how many times the word whale appears in Moby Dick? What if we just want to do that? That sounds pretty cool, right? So we can use a couple of commands all strung together to figure this out. So on Project Gutenberg, there's this URL for all of Moby Dick as a text file. There's this program called curl that is fantastic. That if you give curl a URL, it can standard out. That we can use up Project Gutenberg's bandwidth, and we see book scroll past, which looks pretty cool. You could like put this in an art show. But
oh, is this on your notes? So you can try it out.
Yeah, these are all in the notes if you want to try it out for yourself. So what would be cool is if we can, we can take that output and put it into the input of another program. Just so happens I've already downloaded mobydick.txt. Using a redirect, you could totally do this, and then you can take the output of this command and put it into that file, which I've already done. So now if I just cat Moby Dick, it does the same thing as curling it, but it's faster. So anyways, the next stage is we can take this little program called sed, and this is called a regular expression. There's going to be another little workshop about regular expressions next week, I think. But what this does is it takes every white space character and replaces it with a new line. This is just to make the next step easier. So what it does, if we cat Moby Dick, sure, all of the words are a lot better to format things differently. So we do s+ with /n globally. So now every word is on its own line. That's kind of cool because we can use another program called grep. Now what grep does is if you just type grep, like if I type grep whale, now I say hi, hey there. So grep is just reading from standard input right now. If I type whale, or whatever whale, if I type any text line, and we want to like that. Cool. So now we get all of these lines. So then the next question just becomes, how many occurrences are there of the word whale, right? We can do that just by counting the number of lines. So if we take the wc-l command, th 1323, but this number is just all of the occurrences of exactly the lowercase string whale. So if we want to get all of the cases, we can pass the -i flag to grep, which does a case insensitive search. So whale with a capital W will also match. If we do that, we get this different number, 1692. But suppose we want to do something a little bit different. If we want to search for every occurrence of whale and every occurrence of whaling, and then we can do this thing, which is also a regular expression. So we want to do whale, hang on, You have to do dash E for this. Whale or ing. And we get even more matches because whaling is also. You can ask yourself silly questions like how many times is the word whale or whaling appear in Moby Dick, and get a real answer with Bash. So that's a pretty fun thing that's not at all practical, but maybe you can find a real practical purpose for these tools at some point in the future. Yep.
So pipe takes the output of any program and gives it as the input of another program?
Yes.
And how's it different than this caret that takes the output of any program and...
Oh, like a redirect?
Yeah.
So a redirect with a greater than symbol takes the output of a program and writes it to a file.
It writes it, okay.
Yeah, but a pipe character takes the output of a command and puts it into the input of another command.
Okay.
Yeah. So what's cool though is I can take, if you have a series of things strung together with pipes like this, I can take the output of the last command, which is going to be 1823, and write it to a file like called whalecounts.txt. Now I can cat out what whale count is if I want to like save that to a file for later, for example. You can always like add more terms usually to the end of stuff like that. Right, so curl is really handy. Whenever you just want to look at the HTML of some website, you just type a URL and then it prints out all of the contents. So if you want to scrape websites, it's really handy. If you want to like write little scripts like, what are all the script tags in my website about? Oh geez, sometimes curl does this shit where it puts a progress bar to, it's really annoying, but you can pass in -s, and then it's like, okay curl, don't try to be all friendly, I want. And if you want to get value like this, like if you have a string that includes the less than character, you can use single quotes or double quotes to get around that limitation. So here I'm looking at the output of my website. I just want to see the script HTML tag, for example. There's also the sed command. We talked a little bit about this. This command just takes a regular expression. It finds this is the pattern that it searches for. This part right here. And this is what to replace it with. So that part works, and then grep, of course, just searches for patterns and prints out lines of text that match that pattern. So that's all of the pieces of this breakdown, and then lines or characters or words. So head, if you don't give it a file name, will also read from standard input, but if we give it a file name, if we do head dash n, if I just do head mobydick.txt, I get the first, I think it's, well, how many lines is that? Computer? It's 10 lines. Okay, great. So I get the first 10 lines of mobydick.txt. If I want to get a different number of lines, like the first 2 lines, I can give a different value for -n. So I could write that as -n2, or I could put a space there. Those mean the same thing in this case. Yep. So if the head command didn't have explicit support for reading from files, it only could read from standard in, I could use a redirect like that, the less than. But a fun thing to do with head is to take another program, like if I want to grep for whale in mobydick.txt. Okay, that's a lot of results. What if I only want to see the first 3 lines in the output of grepping for the word whale in mobydick.txt. Name a whale fish is to be called in our tongue, leaving out through. Whales he could anyways find in any book whatsoever, sacred or higgledy-piggledy whale statements, however authentic in these. That makes sense. So another program that's pretty fun, that's built into any Unix system, is called tail. Tail is like head, but instead of printing out the first few lines, you print out the last few lines. So if you give, so if I run tail on mobydick.txt, I see the last 10 lines in the file, which is just some Project Gutenberg garbage. So, but if I want to see the last 100, there's more output. If I only want to see the last line, subscribe to our email. That's great. The tail is really handy if you have, like, if you have a program and it's like making a lot of output, but you only care about the last couple of things. So like, there's a cal command, and we can look at the last 5 lines. Oh, that's not a good example. But anyways, tail starts at the end. It has -n, but it also has -c, which is sometimes handy. So if you want to read the last 20 about new ebooks, or the last 8 characters, books, ebooks, you can also count by characters instead of lines. So that's true of head as well. So that's the tail command. Oh wow, I did exactly the same example in the notes. Wow, that's scary. Anyways, yeah.
Can you say a little bit more about the curl? Can you curl like for JavaScript as well, or CSS?
Sure.
Or?
So there's a JavaScript file. If I curl it, it just prints that. It does.
So on the network, whatever thing you're giving it.
Yeah, I mean whatever HTTP thing you can serve. I could also do that for an image, but it would print out an image to standard out, which would not look very useful on the terminal because the terminal can't show images; it just shows text. But I do that. There we go. That's an image. That's what an image looks like in the terminal. Output, put it in a file, and then look at it with an image viewer.
Could you curl like a link inside of a website that you found?
A link inside. You would have to parse that website,
Okay.
and then with another. Yeah.
On the web.
Then it's going to be like some redirect headers probably, yeah. So it's like 301 moved permanently. This is all of the stuff that your browser doesn't show you, but we'll talk more about this stuff in the networking lecture. Yeah, location https facebook.com. So if you curled that, you would get some output. Or not, because maybe it's like you're using curl. I'm not even going to acknowledge you because we're Facebook. We can do what we want. Oh no. There you go. So it does give you some. Don't show me that stupid progress bar, and I means show me the headers in addition to the content.
I is headers?
Yeah, and you can read all about these in the man
Okay,
page for
cool.
curl. -I. Read all about it. Anyways, another command, cal. Cal is cool if you're on the terminal and you're like, what day of the week is it? What's the date? Type cal. There's a calendar. Pretty cool. That's been there since like the 70s. It's fantastic. You could also do cal-3, which shows you like, oh, it doesn't work well if you have a super small terminal, but, oh, what? Month. Super nice. I do this one all the time. Like, what's gonna be the next days in the next month and stuff? If you have that question, type cal. Cal-3. If you also want to look at all of the days in the current year, or in any year for that matter, you type cal and then the year 2015. Pretty cool. 1856. And that's what 1856 was like. That's pretty cool.
Hell Zero.
Yeah.
Where's Hell Zero? Does it go back forever? And like,
I don't know. Have one to, Cal is not going to work in the year that. Well, it's going to work that.
210K?
Yeah.
Yeah. But it's only going to be this program that breaks. So, maybe not that big of a problem. If you also want to look at a particular month, like October 1994, there we go. So October 1994 is like Saturday, October 1st. That's cool. So another fun thing to type is date. If you want to know not only the day, but also the time. Type date. And we see Sunday, August 2nd at 17:07:59 Pacific Daylight Time, 2015. Pretty cool. Date is fun because it has so if you want to do like a date in a cool format, you can use plus and then like a %y gives you the year. Or like %m is the month and s, or there's this thing like t is the time, capital T. Like this. If you want your date all formatted, all cool like. But you gotta use quotes sometimes if you have spaces. Anyways, date's fun. Another fun thing you can do, well, I guess I'll talk a bit more about that later, but there's this sweet command called fold. I only learned about this one relatively recently, so this is some deep wisdom right here. But fold takes, it's like, I'll just run the command because that's the best way to describe how it works. So if I do fold-w50 mobydick.txt, okay, it's narrower, you might have noticed. What if I do fold 10? It's super narrow, so it's like newspaper mode on the command line. It's pretty cool. Yeah. There's also, there's this other thing, it's special. -s will break on a space, so this breaks on characters by default. So like Guts, Enberg, if you want it to break on spaces, you do SW, and then it's all cool like. So you can read in a really narrow terminal if you want to do that. It's your choice. Fold, like most commands, if you don't give it a file name, it will read from standard input. So you can redirect a file into it, or we can like tail mobydick.txt. You want? It's a narrow column. Fold is pretty sweet. I like it. Play around with fold and head and tail. All fun stuff. Curl we talked about. It's a fun program. grep, we also have talked about this. Okay, backticks. Backticks are some sweet wizard magic because they let you take the output of a program and use that output in a command. So if we have the date command, right? Date plus capital Y gives us the current year. So what if we want to make a new directory with the current year in its name, right? So I want to do make dir super cool 2015, right? But then next year, if I put this in a script, I would have to change my script to make that a different number. I don't want to change my program every year. That's ridiculous. Imagine if that was like the entire date, right? I would have to change it every day. Or if it had the hour in it, I would have to change it every hour. That would be stupid. So what we can do instead to generate this part for us, right? So this command backtick is the one, by the way, beneath your escape key, but above your tab. It's like that one. It's like right where the tilde is on your keyboard. So if I put a command in there, like date, if I just do date, right, it's just going to be the output of the date command. It's sund August, so we don't want that. But if we do like date plus %y, that'll just be the year. So that will run the command make dir super cool 2015. So if I run that, Now we get a new file, super cool 2015. Cool. Or if we want to make an even more practical example, we could put more info in there, like the %F is pretty cool. It's like 2015-08-02 in ISO 8601, which is the best date format. You should read about it on Wikipedia. I'll write it down. ISO 8601. Read all about it on your own time. But F is just that format, so that's pretty cool. So if we want to make dir super cool with like a dash and then the date, it's super cool, obviously. There we go. Make a date. You could also combine this with like the touch commands to make all kinds of like ridiculous numbered files or something with the current date in them. Let's do that. So make a new directory with make dir wow, cd into wow, cover those. We could use the touch command to make a file, make an empty file. So if we touch ABC, we make a file called ABC. We want to make 20,000 files with the date in their name, but numbered. How do we do that? Well, we can use the touch command. We can use a sequence. So 0 to 20,000. Maybe that's a bit much. I'll just do a mere 2,000. But what if we also want the file name to have the current date in it? So what we can do there is use backticks for that part. I will nerf this command with an echo. So if we do date plus %F around backticks in this expansion, what that command will do, and I'll show you with fewer files. What? Oh, 3 dots, 2 dots is what I meant. Yeah, 2 dots is what you want. So this will generate this command. So this would be like if we typed all of that in by hand, which you shouldn't do because computers have much nimbler e-fingers than your own. So if I run this command, it's going to take a while because that's a lot of files, first of all. There we go. There we go. Now we have 2,000 files with the date in their name and numbered. That's pretty cool. With a combination of brace expansion and backticks. There's more, but wait, there's more. So that's a fun little thing, but what else can we do? So there's also arithmetic in the shell. This is just built in. So if you want to do a little mathematical expression, nothing complicated, I hope, but if you want to just like compute something simple, if you use a $, 2 open parens and 2 closing parens, then you can put some math inside. 1 plus 2 plus 3, oh, you have to do it, there we go. 1 plus 2 plus 3, 6. 1 plus 2 times 4 plus 3, 15. Plus 3 times 2, 3 times 3, there we go. Whatever wacky expression you want to put in there, you can do this with a $, 2 open parens. It's a fun little thing to play around with. What's cool though is, suppose we want to take the output of the date command with the year. So to do that, right, we would do date plus %y to get the year. But what if we want to take that number and like Y2K it, so it'll be a problem in 85 years. No, 75. Yeah, 85 years. What if we want to make it a problem in 85 years for the future, because we hate the future? How do we do that? Well, we could use backticks to get the date value, right, 2015. But we could also use that sweet arithmetic trick to like subtract 2000 from it. 15. So called file 15. There's a file 15 in there somewhere. There we go. There it is. We can use arithmetic and backticks at the same time. More stuff. So environment variables. We talked a little bit about these already, but they are something that the shell does for you, and it's a way to store data, store the configuration settings. There's a bunch of built-in environment variables too, but if you now. you'll see this declare, but then you see this, these mostly all capital, but then an equal sign, value. So display, and that's like if you're on Linux, that's how the how graphical programs know where to render. $home with caps, that prints your home directory, if you want to know that. If you want to see what any of these values is individually without scanning the export output, you can just do echo and then like $user, for example, is Substack in my case. We did echo shell at the start of this, and that's been bash. That's pretty cool. So, right, you can echo stuff. What's nice with environment variables is you can also put them inside of any command. So if I want to make a directory that includes my username in it, then I can do make dir xyz $user, and this will make a directory called xyz-substack. An environment variable like that, it'll be expanded by the shell for you. Your own environment variables just by doing like zzz equals 5 will define a variable called zzz, and then I can like echo zzz. Like, if you run a command though, the command won't be able to see that you've defined zzz unless you run this other command called export. So if we do zzz equals 5 but we export it, then if we run another command that's not built about that variable that we created. That's usually only an issue if you're writing your own shell scripts and things, but...
So will then that be stored, like, after you close the shell?
Nope. Goes away.
Interesting.
So there's a special file where you can define variables that you want to be around in your environment, but all of those variables are temporary, so once you create a new shell, like this, then it's not there anymore.
So you export the variable, and then as long as that shell is running, other shells can see it?
No.
Only programs that you've run from this current terminal will be able to see it. It's not like system-wide or anything.
Gotcha.
What's the system-wide one that you said?
There's some different files depending on like if it's your local user or if it's a system thing. There's one file called bashrc in your home directory that starts with a dot. That means you can't see it by ls by default unless you pass ls the -a option, which shows all of the files. But there's this secret file, like if I ls my home directory, it's like, there's nothing there. But wait, there's secret hidden treasures. And you have to give ls the -a option to see them. They all start with a dot, but if you want to look at them, then there's like .dbus, all kinds of crap. But they're totally there. There's secret config directory. This is where a lot of utilities configure themselves. Okay, so environment variables. You can do lowercase ones, but nobody does that. I don't know why, but that's just how it is. There's probably a reason for that. I don't know what it is, but that's just the way things are. Like most things. So if you have some special argument that has like wacky characters in it, like $signs and backticks and junk like that, you probably want to enclose that value in quotes, especially single quotes, because then it won't get expanded. So if we do, like if I did this, like if I wanted to echo some HTML, so Bash would actually see these as redirects and it would do all kinds of stupid stuff. Let's see what it would do. Oh, it just doesn't even try. That's good. But if we wanted that to work, we could just put single quotes around it. If we want to include something like an environment variable, if I put like $user, that's just going to be $user, but if I want to expand that, I can use double quotes. And double quotes are like, they ignore like redirects and stuff, but they will expand environment variables and some other things like backticks for you. So just, you gotta pick which one you use. Or yeah, it's cool because if you have double quotes, you could also put like command in there with backticks. So like date plus %y Substack 2015 example. Pretty sweet. So we've been writing a lot of stuff manually on the command lines using our meat fingers. But how do we save what we're doing into something that we can kind of automate some tasks? So one thing we can do is use this, is we can take all of our commands and put them in a file, and we put this magical thing called a shebang line at the top. So if I make a file called cool.sh, sh is kind of a common convention, but you can name it whatever you like. Then I put a hash symbol and then an exclamation mark, which is just the way that it is. There's no reason for that. And then I do /bin/bash. Then what I've done is I'm telling, when I want to run this file, I'm telling the operating system that, hey, to run me, you should run this program, /bin/bash, which is just the shell. You might also see this used for other things like running Python programs or running Perl programs, whatever. It'll just say something different up top. So anyways, what's cool is now that we're in this file, we can add entries. So if we want to add like some commands, we could do like, okay, make dir with like the current day. Maybe this is a script we'll run every day when we to create 10,000 files, because that's our job. We're like the file creator. We create files. So we're gonna make those files, but first we got to cd to the right place, right? So it's in our home directory and data, and we'll call it work. Oh, but if that directory doesn't exist, we should probably create it first. So let's do make dir-p to create that directory if it doesn't exist. So then we're gonna, then we'll make a bunch of files. 1,000 files. We don't want to like seem too good at our job, right? So something believable. And we'll save those files with the number and the current date. So that's what our program will be like. Then you'll have to run this command. I'll talk a little bit more about this in a bit, but it's called chmod +x. X sets the executable bit on that file. That means that you can run it. So once you've done that, you can do /cool.sh. That will run the program. So when I run this program, it should go into data work in my home directory. If it doesn't exist, then it should go there, and then it should make a bunch of files. So if I run this program using / and then the file name, then, oh crap. So, valid file name.
Plus %. % plus.
Thank you. Good catch. Okay, if I fix that and run it again, then if I go into that directory, data work, a slow train. Just like look at a train all day. Cool.
So why did it need the hash exclamation point bin?
This is called the interpreter,
Okay.
or the shebang line. So this part is the magic thing that just says this is going to be how you execute this file.
And then in order for it to make it executable, you have to do
chmod +x and the file name.
And then to execute it, you do
/cool.sh to execute.
And that slash could be from. Oh, you have to be where it is though.
If you give a relative path, this actually works from wherever you are. So if I do /cool.sh, that will also do the same thing. It just has to be a relative path, and you can't just do cool.sh because it looks in this special environment variable called path to resolve those. So this is like doing a / gets around that. It's a common convention.
Sorry, what was the first line in your program?
Hash symbol, exclamation mark, /bin/bash with no spaces. And then you can just put commands. And it's like you typed them out with your fingers, but the computer did it for you. Even better. There's also, if you want your program to have arguments, there's these special environment variables already defined. Like I'll comment this out so we can just, like it goes $1, $2, $3, etc. up to 9 for each of the arguments. So if you want to say like 1, 2, 3, and run this program, then it'll print the arguments. So if you have arguments that you want to give this program, you can just do that with $, and then the number. And there's a special sweet argument called $* that's like all of the arguments in one go.
Sorry, so then you can give the arguments from the command line?
Yeah.
Oh, okay.
So if you want to make your own whatever program, you can do some basic stuff with bash just directly.
What's the star one do?
It prints everything that you give it. So ABC, ABC. Instead of separately. Okay, cool. More stuff. So arguments, talked about that. Talked about arguments. Oh man, I'm covering, wow, I hardly even looked at these notes, but I'm covering exactly the same things. It's good, I guess. So, a little bit more. How, when you type a command, does that work? So, for most commands that you type, like cal, right? What's actually happening? Well, there's this special environment variable called path. When I type cal, that bash looks to see if there's a cal program is the first entry separated by commands. So does that file exist? Does this file /cal exist? No. Does this file /cal exist? No, it doesn't. Does this file /cal exist? No, it doesn't. No, it doesn't. Finally, and it does exist. So what bash does when you type cal is it eventually finds this file userbin cal, which you can inspect by typing which in front of a command name, and bash will walk your path environment very. So it's common, we might be doing a bit of this on other days, it's common to configure your system so that you have a special place to put your own scripts in your home directory. So like what I've done is I have a prefix directory in my home directory. You can make your prefix. Inside of that I've got a little place I'm working on, and so like I've got one in here called ASP. That's just a little bash script that pipes out to aspell. So it's just some basic stuff that we've covered all these commands. What does that do? I don't even know looking at it, but I wrote it. But if I run this, it will tell me if my spelling is off. So if I do ASP cool, that's correctly spelled, but cool, that's not right. But here's some suggestions that I might have been meaning to type. So it's pretty handy. You can do a lot of stuff on the command line that you'd have to open Microsoft Word and like right click on a letter or something dumb like that. But if I do which ASP, you'll see that it's in that special prefix directory that I set up in my home directory because I've configured my path. How do you configure your path? So you can skip in this. You can edit this file called .bashrc in your home directory. This file is run whenever you start a login shell. So here's my bash RC. If I open it up, it's got some stuff. You know, it's defining some variables, right? It's doing some wacky things. Your system will probably already have one of these that was configured by the system, but I've got some custom stuff in here like xclip. You want there inside of my bash RC. Every time I open a new shell, it'll say hello there. Or what if I want to type like calendar, because I always want to know what time it is. So every time I open a new shell, now I'll see a calendar. That's pretty cool.
That is cool.
And you can define whatever environment variables you want. You can set up your path in here, and then any shell that you open will have that stuff set up.
What file is this?
It's called .bashrc in your home directory. So if you open up ~bashrc, it's fun stuff.
There's no such file or directory.
So if it doesn't exist, just create it.
On a Mac, it's bash profile usually, right?
No, it's something that Bash handles.
Bash. Oh.
If you make this file, if it doesn't exist, just make the file and
Okay.
edit it. Yeah. So
You
another
have to put
thing,
everything else that you had in the file.
you just put it anywhere. You should probably leave whatever was in there because maybe
If there's
it's
nothing,
important.
though, you don't need all that.
Hacking away. So another thing that's worth talking about is permissions. So we've already tackled permissions a little bit when we did chmod plus x and a file name. So permissions are how the kernel decides whether a program has access to a file or not. So one thing we can do is type this command called groups. So if I type groups, I get a list of all of these different names. So Substack, CD-ROM, Flap. That's funny that the CD-ROM group is still there. That's hilarious. Computers haven't had those in a while. But there's other stuff like video, NetDev. These are basically just these are kind of collections of permissions that I particularly have access to. If you pass the -L flag to ls, you'll get a list of the permissions. So if I ls-l a.txt, I see some stuff. I see like some RWs and stuff. So who the owner is and what the group is. So this is owner Substack, and the group is also called Substack because that's just how a Linux system is usually configured for your home directory. But if I ls-l say the root directory, I see that the group is called root, or there's usually like different like whatever these files are. But the important part to look at aside from the owner and the group is the permission. So this part is the permission. You'll see that some of them have X's and some of them don't. Some of them have R's and W's, others don't. So how this works is this is a string. So there's these three letters, right? There's RWX, RWX, RWX. If you don't have permission in one of those three collections of groups, it'll show up as a dash. How it works is the first collection of RWX is the owner. This is what the owner can do with the file. The second collection is the group. That's like what the group users can do with that file. And the third one is everyone else on the system. So what any random user on your system can do with that file. This is sometimes given as a UGO. So the first one is user. It's UGO. Yeah, it's literally that. This is like the user who. And the permissions are read, write, and execute. So if the execute bit is set on a file, you can run it if it's in your path, or if you run it with like // or whatever. Write is just if you can write to it or append to it or whatever, and read is if you can access the contents. So, yeah, UGO, there we go. If you want to change what the permissions are, you can use this command called chmod. There's a lot of different ways to use chmod. It has this chmod plus x. If you want to change what group that is, if you want to be more explicit, when you do this command, you're actually doing the same as u plus x, which means set the execute bit for the current owner of the file, which is implied in the second. Yeah, but it's like the owner user, the user who owns the file.
Oh, I see.
Instead of the group. But if you want to, for example, make it so that your wild.txt can't be edited by any randomer on the system, you can do O. Like and plus X. Okay, then for group, take away R and W. And so you can do
Current user permissions to that file.
it's changing both the current user and the group. So when you see a U or a G, so in this case we're adding R and X for the user, then for the group we're subtracting the read and write. So you might see that kind of stuff, but if you can just remember that like plus X, and then if you just read the man page later or find some Stack Overflow post or whatever, then that'll probably be good enough for most of the kinds of stuff that you'll need to do most of the time. You can also change the owner of the file with the chown command and the group with chgrp, but you shouldn't have to do that too often. Only when you're sort of on a system with a lot of other users and you need to move stuff around. Alright, so there's more. I promise this will end, but there is a few more things that I'd like to get through. One of them is called job control. So job control is how, with the command line, you can manage multiple processes running at once, which is very handy, especially if you're running processes for like a server or whatever.
Wait, so I'm always confused by this. Does that mean it's multi-threaded? Or that it's like parallel? Parallel is like
So your
noun.
system,
it's parallel.
your system can run multiple programs at the same time.
Okay.
Right? So I'm running a web browser and a terminal and some services, and like all of these are separate programs that are running all the time. So in Bash, you can launch multiple programs at the same time and have them be running like in the background or in the foreground, doing different stuff.
Oh, okay. So it's also. Was it always that way? It's not a new thing.
Yeah.
Okay.
It's always been this way, since the 70s at least.
Oh, that's good.
Okay, so anyways, let's play a game to demonstrate some of this. This game is invented by Max Ogden. It's called TimeCat.
I love TimeCat.
So there's this command called time that tells you how long a program took. It's good for profiling. So if you have a slow command, like maybe the calendar command's been. So the calendar command took 0.05 seconds to run. So that's not the best example, but like there's a command called sleep that will sleep for a number of seconds. So if you want to time how long sleep took, it took a second. Good, that's what it should have taken. Like sleep 3 should take 3 seconds. It does, hooray. So you can give the time command another command to run, and it will run it. So if you run the cat program, cat will just sit there waiting on standard input until you do Control D to close it gracefully or Control C to kill it. So what if you run time cat? But what if I try to get to 1 second? Not going over. I went over, so that was a bad one. But yeah, 0.9 seconds. Okay.
That was real good.
Getting closer. Oh, I went over. That was a failure. Oh.
So close.
I just went over 1 second. This is the game of TimeCat. Get as close as you can to 1 second without going over. As far as I know, no one without the assistance of a script has gotten to exactly 1 second.
Wow.
Anyways, so Control C kills a program. Control. It terminates the foreground process, if you want to use fancy words to describe what's happening. There's also another one called Control Z. So if we run cat and it's hanging out, then we do Control Z, we see this thing stopped cat, which means that it took, when we did Control Z, Bash said, okay, that command you're running, I've stopped it, so it's not going to be scheduled anymore. Or we can do bg%1, which is take job 1, defaults to the latest job, but like run it in the background. Unfortunately, this one isn't the best example because it respawns itself, but we can also kill that job. So if we want to stop that job, to kill its if we want to take a job.
Hey James.
Oh yeah.
Question.
Yeah. It takes 0
Whoa.
seconds. It's really meta.
Cool question.
Yeah, you can just stack them. It seems like only one of them takes effect though. Yeah, anyways, so another thing you can do is if you have a program that's running, you're like, okay, I was gonna type some stuff from cat, but crap, I can't remember what I was gonna type. So if you do Control Z, you're just like, okay, that program, keep running. I'm gonna do echo 1 plus 2 because I forgot what that was. It's 3, okay. That's like, okay, now I'm back in cat. So I can type some stuff now, and it's still running. I can even do Control Z again, and then FG again, and like, I'm still back in cat. It's still running. It's the same cat. And then finally, I'll Control D, and then it ends it.
So FG puts you back from terminal back into your program?
Yeah. If you had one running last.
And if you have multiple stopped jobs, it'll FG without an argument will go to the most recent one you stopped.
Yes. So you can explicitly tell FG to just be the last one. And that number is just like when you Control Z, there's a little number there. What is that? Yeah, another way to automatically background something without hitting Control Z is to put an ampersand after the command. So if I do like the node command, which is a handy little REPL, so this job has already been stopped and put in the background. But if I type FG, I'm back in that program. Cool. Cool. And then if I do Control Z, something in the background, but a lot of the time this will mean that the job is stopped. So you can run this other command called bg, which is like, okay, background that process. But, yeah, there's usually better ways to run stuff though than this. Whoa, that's weird. Okay.
What did the ampersand stand for again?
The ampersand is like if you'd hit Control Z right after it started.
Okay.
Cool. And so that's Control Z, backgrounds a process, or Control C kills a process, Control D ends the standard input of a process, and the jobs command lists all of the jobs you have on the system, or on the current shell, not system-wide, and you can use kill with a job number % to stop a job. Another fun thing you can do is called pgrep. So this lets you search for a process ID, which is different from a job number by its name. So I happen to know that I'm running a process pgrep node. I get some process IDs, like 2 of them in fact. If I want to have a little bit more info, I can pass some extra flags, like LF is a good one. And that says, okay, this one is sudo, but this one is node, and that one's node. Okay, that's not the best. Whatever. pgrep node LF. Oh, that one's not running anymore, but anyways. with pgrep you can search for different stuff like Chrome. Oh, there's all the process IDs for Chrome. You can also, if you want to kill, like, there's this kill command. So if you want to kill Chrome, you could type in all of those numbers to kill, and then it would kill those programs. But there's an even cooler one called pkill that will just kill everything. Right? It's like, fuck Chrome. It's gone. And we can verify that by running pgrep. So, it's all gone.
So jobs should show all of the programs running?
Jobs should only shows all of the like backgrounded processes and things like that in your current shell.
Oh.
So if you had a different shell running, it wouldn't.
What if you want to see the programs of all the computer running?
You can use PS. PS AUX prints and level stuff like all this root crap. I don't know what that does, but
So you could launch Chrome from a shell, yeah?
yes.
You can launch any program.
Yeah. So where is it running when I launch it, like from its icon in the GUI? Is that in a
GUI is a login shell. So the login, yeah. So basically, once you hit the ground running, once the kernel boots up, it like kind of like hands off like the login system, runs other programs. But if you launch it from the GUI, you're not going to see like what happens on standard out. Like Chrome actually has a lot of messages on standard out whenever you do stuff. It's like that's where it puts all the debugging info and warnings and stuff that you just never see as a user. But if you run it on the command line, you can see.
From that terminal, if you're like, oh well, the program's running, guess I can close that terminal. That'll also stop your program.
Yeah. So, is that different on a Mac? Sure. Or
Themselves. Hey, I'm hiding away somewhere else, but it's still a program running, but it can do this little dance to sort of get away. Yeah, killing. So a fun thing. Maybe we'll do that another day because I'm getting a bit tired. But that's pretty much it. If you have questions and stuff.
Thanks, James.
Yay.
Woo!
The notes are on the GitHub org.
Yeah, I mean, when I'm learning to program, the one thing I really regret not doing is learning more shell scripting and going deeper. I just kind of stay stuck at one level. So these notes, like repeating these notes will help me.
Also on the GitHub, if you go to the external resources, there's a whole bunch of like other things you can do, exercises, other websites, things. There's lots of really nice bash and shell. Like the Linux Command Line by William Schatz is a really, really nice book, and the full text is available for free online. And it covers like writing scripts and like all this stuff. It's not just a reference.
How do you kill the streaming?
I don't know, but look at how cool it looks with white. It didn't look like that. I think we push. There should be like a button with a record, start stuff.
What
Done.
about the live stream?
It'll stop as soon as it stops receiving data.
Okay.
Was it recorded too?
So that took a while, but that's like the longest lecture, they won't all be like this. They'll be much. It's just this one's so important.
Yeah, this is really cool. There's a lot of stuff. I've been using the terminal for a while, but there's still some stuff that you had that was pretty wizardy.
Cool.
It's definitely easy to get stuck at it, though. Just get stuck at just a functional, just like able to get around level.
Yeah, it
I've
can
been
be
stuck there
difficult
for many
sometimes.
years. I just need to. It's weird because you use it so much every day,
Yeah.
like not getting better at it. So like,
I don't know if it's kind of one of those things that's kind of a bottomless pit of learning. You're never really done learning.
that's true.
And people are always writing new scripts that you're like, oh shit, that's super useful. I gotta learn how to do that. So, kind of like Vim. Never really done learning that.
Over a little bit of a learning curve. It's very difficult to use to go back to using other tests.
Oh really? That's interesting. Yeah. I don't know.
I'm not like a master by any sort of
Master.
Yeah.
The master.
Are you uploading it?
but it's like
The
super
video?
yeah, it's just
Well, the
super
video was
awesome,
already
like,
streaming on
as a
YouTube,
but
so
Oh shit, that's even better.
yeah.
Yeah.
So
Okay.
it should just like
So that's
Other than like uploading different stuff. Okay.
no SD card.
Oh.
What I use is this big for like taking whatever was on the SD card and making it small enough to be able to upload it to YouTube. And this command would take all night to run on one file.
He showed us how to
It's
like,
so horrible.
what do you do? He like
Hangout
download
time.
so that
in
the
his
pound
text editor to,
exclamation
like,
point
automatically
bin bash
compile
is
and
just
run
that way
his
because it
C
was always
scripts
that
only
way.
if it
It's
was
still
used
I,
streaming.
that's always
other files.
confusing.
What?
Just like
Maybe we have to
it's
turn
just
that
like,
thing
it's just
off.
so simple to
Swing
like
it.
flip
I
through
see,
it.
What?
not
And
see
I've
what
seen
I just
people that
said.
I've
Wow.
like programmed with where they have like Vim bindings for everything.
yeah.
But everyone has a
So
Vim
it's
binding
still
code
up as
for,
a
like,
stream.
Chrome has one and
Stop.
all that.
Yeah.
So he was just able to like fly through
Yeah.
everything because it's all one key binding
Stop
scheme.
stream.
Yeah, it's also and there's a
Where are the
I've been using that
talking
I think like Vimian for
On the
Chrome.
GitHub,
Keybind, Chrome keybind or Vim
Under-
keybinds for Chrome.
Yeah.
I think
It's,
he
I've got
calls
a-
it Unix.
I've recently started encountering like conflicts with like
Is it still
native
streaming?
keybindings.
Oh,
It
shit.
is stopping.
Yeah,
It
well,
hits
I don't know. There's an
sometimes,
image.
like, when
Oh,
you're-
yeah.
when you're
Move the
using,
camera.
like different like control keys and so on.
It says it's
But
stopping.
pretty awesome,
Yeah, it's
though,
stopped.
like, just like
Okay,
navigating the
great.
web.
Ah, very good. So we
Yeah,
had to
yeah.
stop.
It's really
Oh yeah, because I
interesting,
stopped the
but,
camera.
Yeah, it's just
But
a,
we had
yeah,
to
there's just
stop
that learning
the-
curve.
It might just be lagging.
The-
Hold on.
the
No, it's still
thingy.
streaming.
It's such reduced
Really?
productivity
Yeah, you
for a
just
minute.
walk
Like,
the shot.
What?
I don't know, like in the like week or two that I was trying to do it, just like actually programming.
How?
Like you can't control.
We could just
speed,
unplug it.
Like
No,
copy and paste.
Oh,
like,
what if we unplug it?
Yeah.
I'm unplugging it.
It's
Okay.